Hello, in this video we are going to learn about the linear speed and the angular speed. Let's begin. So suppose an object moves along a circular path with the radius is r. So to find the linear speed, we will call it v for linear speed. We will take the ratio of our arc length over the time. So again, v equal s divided by t. It means that the linear speed equal the arc length divided by the time. And if you don't remember the formula to find the arc length is the product of the radius and the angle theta in radian. So that is the linear speed. So again, linear speed is the ratio of the arc length over the time. Next, let's move on to the angular speed. So if theta is the angle of rotation in radian, theta must be in radian, through which the object moves during time t. Then the angular speed equal the ratio of our radian over time t. Okay, so again, angular speed we use omega equal to theta divided by t. So angular speed is the ratio of our angle theta in radian over time t. So let's begin with the example. So a typical vinyl record has a diameter of 30 centimeters. So again, this is the diameter. So you have to find the radius from here. When placed on a turntable, the record spins at 33 1/3 revolutions per minute. Keep in mind that one rotation or one revolution is 2 pi radian. So you have to convert this 33 1/3 revolutions into radian. Find the angular speed, and we want the unit is radian per minute of a record at its place, round to the nearest 10. So let's go ahead and start with convert the number of revolution to radian. So we know that each rotation equal 2 pi radian. So 33 1/3 revolution we can convert to radian by taking 33 1/3 times 2 pi. So that will give us 66 2/3 pi radian. So that will be our angle of rotation theta. Now we can find the angular speed. So the formula to find the angular speed is omega equal theta divided by t. Okay, so angular speed equal the angle in radian divided by the time t. Okay, so we're going to go ahead and substitute what we have. So we have our theta is 66 2/3 pi radian, and our time is 1 minute. And we are going to simplify this, so it will be about 209.4 radians per minute. Now let's look at the next example. So we still use exactly the same data. So again, it's still about the vinyl record. but we want to find the linear speed. So again, the first step, we have to convert the revolution numbers, the number of revolution into radian. And we know that one revolution is 2 pi. So we just take 33 1/3 times 2 pi, that gives us 66 2/3 pi. And you don't have to write the unit radian, we all know. Now we go ahead and use the linear speed formula. So V equal S divided by T. So this is linear speed equal the arc length divided by time. So now you will substitute. So S, we have to substitute S for the product of radius r times the angle radian theta. So times the angle theta in radian. Now we substitute our R for 15. We substitute our theta for 66 2/3 pi, and substitute our T for 1 minute and put in your calculator. So we simplify first. The numerator will be 1000 pi, and now now we have to convert it, because the question wants us to convert it to so they want us to write it at centimeter per second. Okay, so we have 1000 pi centimeter per minute, and each minute is 60 seconds. So now you can see that the unit, the minute unit is gone. So now we end up with the centimeter per second. So it's about 52.4 centimeters per second. Okay, so let's look at this example. Can you help us to find the angular speed? Given the diameter is 6 feet, and it rotates at a rate of 10 revolutions per minute. So keep in mind that we only give you the diameter, so you have to find the radius, and you also have to convert the number of revolutions into radian. Given 2 pi radian is 1 revolution. The answer is 62.8 radian per minute. So let's check your answer with us. So the first thing, again, we have to convert so we have to find out theta, the angle theta in radian. So we will have to take 10 revolution, and we will go ahead and multiply by 2 pi radian per 1 revolution. So now that will give us 20 pi radian. So now our angular speed omega equal theta divided by t. So this will substitute our theta be 20 pi radian, and t in this case will be 1 minute. So this is radian per minute. And then you will put in your calculator. So it's about 62.8 radian per minute. Okay, thank you so much for pay attention and take note with that. Thank you.